Okay, today we're solving inequalities with absolute value. So, in other words, we're going to have an inequality sign instead of an equal sign. As a reminder from algebra, if you have a greater than or less than, you're going to have an open circle because you're not including the point. If you have a greater than or equal to or less than or equal to, you have a closed circle. So if you are equal to a point, you have a closed circle, you will include that point. This gives you an example of what your solutions are going to look like when you have inequalities. You're going to have 1 point here, 1 point here, and a line drawn in between because it means you're including all the solutions within these 2 points. Or your solution might look like you have a point here and a point here with your arrows going in the opposite direction. It means all solutions will work in this direction. This direction is just the things in between. Those solutions will not work for the problem. This means only these solutions in between the point work for the problem. This means everything outside those points going in both directions work for the problem. Just trying to give you an idea of what your answers should look like. Look at 29C, 1 through 4. You have the absolute value of x plus 2 is greater than 5. You solve it just like it's an equal sign. That's the start of it, okay? So from last lesson, to solve this like it's an equal sign, you want only absolute value on one side and only a number on the other side. And then you can set whatever's in the absolute value equal to a positive of that number. Then you can set it equal to a negative of that number. Solving for x, this one, without going through the motions, subtracting 2 to the other side, that would be x equals 3. Subtracting 2 to the other side, that would be a negative 5, negative 2. That would be x equals a negative 7. Okay, so then what you do is you plot those points on your number line. So x equals 3, that's positive 3 right there. It's an open circle because it's greater than, it's not equal to. So I'm going to have open circle because I don't want to include 3. Then you go to an open circle at negative 7, so there's that. Then what you do is you test points in between. So is my solution either going to be everything in between these 2 points or everything outside those 2 points? So what you do is you basically pick a number between these 2 points in here. Then you can pick a number over here, then you can pick a number over here, okay? Normally, like the way I started is to pick a number in between the 2 points. Well, 0, that's the easiest number to pick, okay? So if I put in 0, so here's my test case for in between, okay? So I'm picking x equals 0. So everywhere in my thing, put in x equals, or 0 for x. So that'd be 0, the absolute value of 0 plus 2 is greater than 5. Is that a true statement? 0 plus 2 is 2, and the absolute value of 2 is just 2. Is 2 greater than 5? No. That is a false statement, meaning nothing in here should work. If you put any number that's in between these 2 points, in between here, they should all be false. Like, I'll give you another example. Let's say x equals 1, putting in 1 right there. 1 plus 2 is 3. The absolute value of 3 is just 3. Is 3 greater than 5? No. Okay, so nothing in between those 2 points will work. So pick a test case out here, something bigger than that. All right, let's pick 6. Okay, so then for x equals 6, put in 6 for x. 6 plus 2 is 8. The absolute value of 8 is just 8. 8 is greater than 5. Yes, true statement. Okay, go pick something over here outside this point. Let's pick negative 8. So that would be negative 8 plus 2. I'm putting in whatever I'm picking for x. It's greater than 5. Negative 8 plus 2 is negative 6. Is the absolute value of negative 6 greater than 5? Yes, because the absolute value of negative 6 is a positive 6, and 6 is greater than 5. That's a true statement. So, meaning nothing in between the 2 points will work, but any number outside these points will work. So you draw a line like this, and you draw an arrow saying that any number that is smaller than negative 7 will work, and any number greater than 3, but we're not including negative 7 and we're not including 3. Meaning I could use 3.1 or 3.001. So this is what your solutions should look like. Now let's look at 29C, 5 through 8, and pretty much everything that I just did answered all those questions in the book. Okay, so looking here, you want to make sure you have absolute value on one side and a number on the other side. When you have that, you get two solutions for x just like you did for last lesson. So you take everything in the absolute value and you set it equal to a positive one of those, and then you take it and set it equal to a negative whatever that is. And then you solve for x. So add 2, so 3x equals 6, divide by 3, so x equals 2. Over here, 3x equals, that would be a negative 2, divide 3, so x equals negative 2/3. These are your 2 points to plot, okay? So on your number line, and by the way, we have less than or equal to. The fact that we have an equal to means we want a closed circle. So go plot x equals a positive 2. So at positive 2, I have a closed circle right there. Then negative 2/3. So that's, you're just estimating that's somewhere in between 0 and negative 1. So I'm going to make it like right there. So now we're picking test cases. Our solution is going to be one of two things. It's either going to be everything in between these 2 points with a line straight there, or it's going to be everything outside those 2 points. Normally what I like to do is just pick a point in here. If that's true, then I know it's in between. If it's false, I know it's everything outside. So easiest number to always pick, 0. Okay? So testing here in the middle, putting in 0 for x. That would be 3 times 0 minus 2, absolute value of that, less than or equal to 4. 3 times 0 is 0. 0 minus 2 is negative 2. The absolute value of negative 2 is a positive 2. Is 2 less than or equal to 4? Yes, that's a true statement. Okay? Which I can conclude, I'm still going to test the other points just so you can see. Since that is true, I will conclude that everything in between those 2 points will make it true. And my solutions would be everything in between those 2 points. But just to verify, let's pick 6. Okay, putting in 6 for x. That would be the absolute value of 3 times 6 minus 2 is less than or equal to 4. 3 times 6 is 18. 18 minus 2 is 16. The absolute value of 16 is just 16. 16 is not less than or equal to 4. That's a false statement. Alright, let's go pick, I don't know, let's just pick negative 2. So it would be the absolute value of 3 times negative 2 minus 2 is less than or equal to 4. 3 times the negative 2 is negative 6. So then we have negative 6 minus 2. Negative 6, negative 2, that would be absolute value of negative 8, which would be a positive 8. Positive 8 is not less than or equal to 4, so that is a false statement. So that just proves nothing on this side of the point or that side of the point works. It's everything in between the 2 points. Okay, now we're looking at 29D, 5 through 8. You have this. Remember, the goal is to only have absolute value on one side, numbers on the other side. So therefore we need to subtract this 2 over. So then we have the absolute value of 3x plus 2 is greater than 1. Now that we have absolute value on one side, number on the other side, you can take whatever's in the absolute value and set that equal to a positive, that answer. Now you take it and set it equal to a negative of that answer. Now we just need to solve for x in both of those. So subtract 2 over, so 3x equals negative 1. Watch your signs. Divide your 3 over, so x equals negative 1/3. Watch your signs, so 3x equals negative 3. Divide the 3, so x equals negative 1. Now you can plot those points on your number line. So this was a greater than, so they both should be open circles. So x equals negative 1/3. That's over here, not quite to 1, something like there, and it's just an estimate. And then x equals negative 1. So there's your 2 circles. So since these are so close together, my recommendation is to test something out here. If these are both false, then you know that everything in there is true. So that would be the easiest way to do that. So I'm going to test 2. Okay, so down here, the absolute value, 3 times 2 plus 2. I'm putting in 2 for x. Go to the original equation, because you know that that's not wrong. That way there's no mistakes on that. 3 times 2 is 6. 6 plus 2 is 8. The absolute value of 8 is just 8 plus 2 is greater than 3. 8 plus 2 is 10, and 10 is greater than 3. That is true, which means this over here is true. Okay, so now let's go test one over here. So let's do negative 2. So the absolute value of 3 times negative 2 plus 2, okay, that's the original equation, putting in negative 2 for x. 3 times negative 2 is negative 6. Negative 6 plus 2 is a negative 4. The absolute value of negative 4 is a positive 4. Plus 2 is 6, greater than 3. That is a true statement. So that was true. That means that if I was to pick a number in between those 2 points, it would be false. So therefore my answer is everything outside these points, going that way. That would be your solutions. Alright, look at 29D, number 12. For the instructions of these, always read your instructions. For the instructions it says, you're either going to be writing all solutions, some solutions, or no solutions, or none. Okay? So, looking at, actually let's go over here to 29C7. Let's do this one first. So, here, if we were to solve that like we just did the other one, so then we would have x minus 7 equals 2 and x minus 7 equals a negative 2. So going through and solving that, add 7 there for both sides, x equals 9, add 7, x equals 5. So you'd be plotting those 2 points. And when you plot those 2 points on a number line, you're either going to come up with this answer, where it's in between, or you're going to come up with something like this. Meaning that this problem, not every number on the number line is going to work. Some numbers do work, but not every one. So since this would represent some, this would also represent some, then for this one, some. Your answer here is just like all the problems we've been working, that would be some. Some solutions work. Okay? Now, let's look at this one right here, 29D, number 14. So, again, the idea is to get absolute value all by itself and get numbers together. So, subtract your 10 over. So now you have the absolute value of 2x plus 7 is less than negative 9. Well, less than negative 9, that means negative 10, negative 11, negative 12, any number would be more depth than that. But when you take the absolute value of any number, it will always be positive. I don't care what is inside here. I could cover all that up. The absolute value of anything is a positive number. And a positive number will never be less than a negative number, ever. We will not be more in depth than negative 9. Because when you take the absolute value, it's always positive. So this is none. No solutions. Okay, look at this one. 29D13. The difference between here, the absolute value of something less than or equal to 0. Here's the tricky part on this one. The absolute value can never be less than 0. It can never be a negative number, but it could be equal to 0. So, because if you're doing the absolute value of 0, that's still 0. So, what you can do to solve this, 3x minus 4, we said it could be equal to 0. Will never be less than 0, but it could be equal to 0. And then when we go to solve this, that only gives us one solution. This has an exponent of 1, which means one solution. So for here, this one, we're only going to have one solution. It was kind of tricky because they don't give you the option of one solution. So that one will only have one solution. Look at 29D, number 12. Same thing, but now we're greater than or equal to 0. Well, greater than 0 means all positive numbers. And equal to 0, 0 is not considered positive or negative. So if I took the absolute value of anything, no matter what this number is in here, the absolute value will always be greater than 0. So this one would be all solutions. Because anything, the absolute value, if it makes it positive, that will always be bigger than 0, and yes, we can still be equal to 0. So this one would be all.